Now we're going to move on to the compositions of functions. So the first thing we're going to do is think about functions as a sequence of actions. Thinking of function in this way will help us define what composition of function means. Then we're going to find the composition of some example functions. Alright, so a function f can be thought of as an action on inputs. That's part of our input-output model, right? So you take your input x, you do some kind of action to x, and that gives you your result, which is f of x. So for example, if we're looking at the function f, whose formula is given by f of x equals 2x plus 3, we can actually think of this, actually not just as one action, but as two actions, right? So you start with x, and the first thing you do is you multiply by 2 to get 2x, and then you take that 2x and you do an additional action of adding 3 to get 2x plus 3. So f could be thought of as the action of multiplying by 2 and then adding 3. Which means that you could think of f as being made up of two different actions. Which means that since each action is a function, f could be thought of as being created from two different functions. So if we're looking at f of x equals 2x plus 3 and we want to sort of break down f of x, or break down f in terms of those two functions, that first function is going to be the multiply by 2 function, right? The first action is multiply by 2. What does the multiply by 2 function do? It takes an input x, multiplies it by 2. So it's going to be g of x, x is the input. When we multiply that by 2, we get 2x. The second one, the second function that it's made up of is the add 3 function. That takes an input x and adds 3 to it. So we'll call that h of x being given by x plus 3. Remember, x is the input, and if you're adding 3 to the input, that's x plus 3. So if we want to think about f as being made up of these two functions, well, let's see. The first thing we're going to do is start with x. We're going to multiply x by 2 to get g of x equals 2x, right? That's the first part of our action. Now, the second action is the plus 3 action, right? Now, h of x equals x plus 3, that adds 3 to x. But we don't want to add 3 to x. We want to add 3 to 2x, right? But again, think of h as the function that takes your input and adds 3 to it. If our input is x, we get x plus 3. If we want to add 3 to 2x, that means that 2x has to be our input, right? So for f of x equals 2x plus 3, we want to add 3 to 2x, which means we don't want to look at h of x, we want to look at h of 2x. So if 2x is our input, and if h adds 3 to the input, that means h of 2x is going to be 2x plus 3. So our f of x is equal to 2x plus 3, which, as we've seen, is h of 2x. But which, as we've also seen, 2x is equal to g of x. That means our f of x is equal to h of g of x. So we start with x. We do g of x to that to get 2x. And then we do h to g of x to get 2x plus 3. So this is how we're going to define the composition of two functions. If you have g and h are functions, the function h circle g, which is the composition of h and g, is just going to be h circle g of x equals h of g of x. In terms of actions, we do the action of g first, then we do the action of h. So visually, that means we start with x, we do g first to get g of x, and then we do h to that output, h of g of x, gives us the composition of functions. So let's go ahead and try that on a pair of functions, the g of x being square root of x, and the h of x being x cubed plus 1. So if you want to think of g of x as an action, it takes an input x, takes its square root. If you want to think of the h of x as an action, what we do is we take our x, we cube it, and then whatever that is, we add 1 to it. So we're going to go ahead and actually find both g circle h of x and h circle g of x, so we can sort of do it both ways. So if we're looking at g circle h of x, what we're doing is we're looking at g of h of x, which means we're doing h first, and then we're doing g. Now h of x is literally just x cubed plus 1, right? So when we say g of h of x, that's just going to be g of x cubed plus 1. Now, if we want to actually figure out what g of x cubed plus 1 is, think about what g does. It takes its input x and takes its square root to get the square root of x. So whatever its input is, it takes the square root. In this case, its input is x cubed plus 1. So the action it's going to do is take its square root to get square root of x cubed plus 1. If we're doing it in the opposite direction, h circle g of x, we're going to do, that's h of g of x. We're going to do g first, then h. Well, g of x, we know what that is. That's just square root of x. And what does h do? It takes its input, it cubes it, and then adds 1. The input in this case is the square root of x, so it's going to cube that square root of x, and then add 1. So g circle h, we start with x. We do h first to get x cubed plus 1. Then we do g to that to get square root of x cubed plus 1. If we're doing h circle g, we start with x. We start with g to get g of x equals square root of x. Then we do h to get square root of x cubed plus 1. So here's an example of finding the composition of functions, at least at some points, using their graph. It's another useful way of understanding composition of functions. So let's see if we can find g circle f of 1. So remember, we do f first and then g. So the first thing we want to do is find f of 1. So f of 1, let's see. If we put in x equals 1, it's kind of hard to see the point there. It's 1, 2. But if you look at the grid lines, we go 1 to the right and 1 grid line to the right. We could do 2 grid lines up. That means x equals 1, y equals 2. So if we want to find f of 1, that's going to equal 2 because 1 is the x coordinate, that's our input. 2 is the y coordinate, that's our output. So now if we want to find g circle f of 1, we want to find g of f of 1, which again, we just found f of 1 that's equal to 2, so that means we want to find g of 2. In this case, we want to figure out what x equals 2 gives us for g. G is our blue one. And then figure out what the y coordinate of that is. Well, if you notice what that point is, again, reading the coordinate on there might be hard, the 2, negative 4, but you can see that you're going to go 2 grid lines to the right, 4 grid lines down. That means g of 2 is equal to negative 4. So that means if we want to find g circle f of 1, that's g of f of 1, which we just found out was negative 4. Alright, so just remember when we're doing composition of function, it's a little bit counterintuitive, but the actions are done right to left. So if we want to do f circle g, we do g first, then we do f, which means we start with x as our input. We do g to get g of x, and then we do f to get f of g of x. Alright, so I think this prepares you pretty well to work on the first set of activities. It's called Composition of Functions. It's the PDF file that is included with this video.